Hi, and welcome to our third video on simultaneous equations. And what we're going to be doing in this video is just having a look at how curves and lines relate to each other, how many times they meet, and in what ways they meet. And we're going to be using the discriminant to help us with our understanding of that, and also using facts about the discriminant when solving problems. Now, we saw in the previous video an example where we had a curve and a line that didn't meet, and we used the discriminant to understand why that was happening. We know from the discriminant that we've previously looked at it and looked at it in terms of how many times it goes to the x-axis. What we're going to do now is look at it in terms of what happens with a curve and a straight line. You can see on the diagram here, we've got 2 points of intersection, and if that happens, we've got two real and distinct roots, so we know that b squared minus 4ac is greater than 0. Second example, we've got just one repeated root. The line and the curve meet in one particular place. We know from that, if we've got one repeated root, that means that b squared minus 4ac equals 0. And what that means is the line is a tangent to the curve, i.e. the line just touches the curve and then goes away from it again. It doesn't actually go through the curve. And then the final situation we can have is when the line and the curve have no roots at all. So b squared minus 4ac is less than 0, let's say, and the curve and the line just don't intersect anyway. So those are basically the three different things we can have. And I've illustrated it with diagrams where the curves are quadratic, but this could apply to circles, reciprocals, or any other kind of curves that you care to be working with. So let's have a look at how we might be asked to use our understanding of discriminants and points of intersection. So here we've got an exam style question. We've got a straight line, that's that one there, and you've got a quadratic, but we don't know everything about the quadratic. We just know we've got this thing k here, which is just a number, and we've got to work with that information to begin with. So to start off with, it's going to be broken up into questions. Let's do part A. So we've got, it's just to show that, so we've got to prove that we can start with these two equations and end up with this one here, x squared plus 8kx plus k equals 0. So off we go. Let's start by rearranging our equation, make it say y equals. Simple enough to do. And then we've just got to substitute that into our second equation. So now we've got to multiply out the brackets. And notice you've got that plus sign. Be careful with these signs. You've got a minus and a minus. That's why that's becoming a plus. And do a little bit of tidying up. And that's the result that the question was asking for. Okay, on we go to part B. We're given some more information. We're told that x squared plus 8kx plus k equals 0. It's got equal roots. So what we've got to do is work out the value, use that information to work out the value of k. So equal roots, straight away when you see a phrase regarding roots, straight away you're thinking about discriminant. And so we know in this case equal roots means b squared minus 4ac equals 0. So in this case we've got, there's our value of b, 8k, there's c, there's a. I've gone about them in a slightly odd order, but you kind of get what I'm saying. So b squared minus 4ac. Be very careful when you're doing this. The number of times you'll see students taking this right. This is 8k squared without the brackets, and what that means is you end up squaring the 8 and you'll end up with an incorrect result. But we haven't done that here. We've made sure we've done it correctly. So let's deal with the squaring. We've got now a quadratic equation in terms of k that we've got to solve. So I'm going to take out a factor of 4k, and that leaves me with two solutions, k equals 0 and k equals 1 over 16. At this point, I'm looking at this thinking, well, I've ended up with two solutions, but hang on a second. It says find the value of k, as in value, not values, singular. We've only got one value here. I've got two, so what's going on? Well, the key to that is actually in the question up here. It says k is a non-zero constant. So we've got our value of k equals 0 here, so we're told that that one can't be k, so let's ignore that. And so we've got k equals 1 over 16, and that's our value of k. On we go, on to part C. It says for this value of k, so when k is 1/16, find the solution to the simultaneous equations. So we've got k equals 1/16, and so all we've got to do now is to put that in and solve the equation that we had there. So we've got x squared plus half x plus 1 over 16 equals 0. Now again, up to you how you solve it, but if you're really sharp-eyed with this one, you will notice that that can be written as a perfect square. So I'm just going to put that bracket in there, and you might have spotted, well, we need a number that times by itself makes 16, and two lots of it add to make a half, and that value is going to be a quarter. So if you just want to pause there, if you want to just have a little think about and make sure you're happy with why that's working. And once you've done that, you can see, well, we've got x plus a quarter all squared equals 0. So x equals minus 1/4. Obviously what we've got there is technically two roots, x equals minus a quarter and also x equals minus a quarter. But obviously it's two roots occurring at the same time. So that's our solution to the simultaneous equation. We've got x equals minus a quarter. Clearly we need to work out the other part of that, which is the y value. And there we are, y equals 3/2. And so on to part D. It says describe geometrically the relationship between the two curves. Well, the curves we've got our straight line here, and we've got this curve here, but we now know that k is 1/16, so we're looking at an equation as x squared minus 4/16y plus 5/16, and because we've only got one solution, one point of intersection, we know that the straight line is a tangent to the curve. So that's what that kind of discriminant equals 0 is all about, as we saw on the previous slides. And let's just have a little look at what that looks like. There you go, there's your curve, and there's the straight line, and clearly we've got a straight line. The blue line is a tangent to the curve.